Izzat bin Mahtarudin. I'm from Group 1 and I will explain about concrete steel composite beam. Okay, composite are construction material made by combining two or more natural or artificial material that are stronger as a group than as individual component. Okay, next, composite are typically designed with a specific goal in mind, such as increased strength, efficiency or durability. Okay, next, composite material allow high strength and modulus to weight ratio than conventional engineering materials. Okay, next, the increased fatigue performance of composite material allow them to be applied to rehabilitate fatigued metallic A-frames. After that, some of properties are in direct contradiction to one another. Okay, last, steam beam are attached to a concrete slab in such a way that they function as one unit to create a composite beam.
Hai, Assalamualaikum. My name is Nurul Haryani Afidah binti Muhammad Arifin. Nomor metrik DF200156. I will present about background study section. Okay, a composite beam are a form of a beam that combines concrete and steel to create a strong structure. The background of study of the research was the steel concrete composite beam for this project to minimize the risk of unserviceability or failure of the structure during its design life to an acceptable level. Designer must care for the random nature of loading, the variability of materials, and construction problems. The focus of the study is to research the strength and analysis of steel concrete in composite beam for simply supported beam in the structure. The steel composite beams might be a particularly beneficial option in bridge application, where severe condition and stringent maintenance needs provide engineer with an ever-increasing difficulty. In such application, the stainless portion might be kept exposed to the local environment with no long-term maintenance requirement, lowering life cycle costs compared to carbon steel while simultaneously using stainless steel great aesthetic appeal. Thank you.
Hi, Assalamualaikum. My name is Muhammad Ali Firwan from Group 1. Today I'm going to explain about methodology. Concrete wall and a steel and concrete surface with strength connection cast on top make up steel concrete combination spans. Due to lack of a connection between the steel beams and the slab, they behave differently under pressure. Advantages of composite beam. First, the cement and steel are put to good use. Second, for the same length and loading, composite material use more cost-effective steel section than non-composite construction. Next, covered steel beams are better in fire and corrosion resistant. And lastly, composite beam has a better rigidity than steel beam, resulting in less deflection. For composite slab are made by pouring concrete on top of profile steel jacking. And next, for composite beams, shear connector joins a steel beam with a reinforced concrete slab to form steel concrete composite beam. For downstem beam, through that soldered shearing screw are used to link a downstem pillar to a composite slab. A prefabricated concrete surface, on the other hand, is placed on top of the steel plate, column cord. Next, for shallow floor. Shallow floor band floorboard are those with the majority of the steel plate inside the slab layer and can be found in the length range from 4 to 9 meters. Next, composite column. Composite column can be extremely strong despite having a small cross-sectional area, allowing for more floor space to be used. Composite column come in a variety of shape and size, the most common of which are a steel hollow cylinder, form of concrete or an open steel segment buried beneath. Theoretical comparison. Theoretical data for material based on linear stress distribution. Correlation is compared to a new product and service linkage. The applied force range investigated is representative of the beam's response in affordable conditions. For alternative method, understanding the difference between research and configuration segment is crucial. Next, when an examination is done, investigating segment are the segment attributes that are used to construct the model. The plan area is whichever component has been planned to the most recently and hence been allocated the current plan area. It is feasible for the most recent investigated area and the current plan segment to be exceptional. For example, a test may have been performed using an IPE 400 bar, but it was later determined in the plan that IPE 500 bar perform better, which is size of bin in European. That's automatic.
My name is Muhammad Al-Fadi bin Mashur Zaman. My latest number is TF2017. Today I will explain about the part of the solution of this project. So the dimension of the complete staging is 250 times 100 and 250 times 400. Then for the elastic modulus for the concrete is 50 gigapascal and for the steel is 200 gigapascal. So N equal to elastic modulus 1 divided by elastic modulus 2. So 200 divided by 50 we get N equal to 4. The width of the concrete will then be multiplied to N to obtain the new area, which is 250 times 4 that's equal 1000 meter. Then Y bar equal to summation of YA equal to summation of A. Then summation is Y bar is natural axis, and then sum of center of piece and times area of piece, then divide by summation of area of piece of block. Then in the table we get piece number 1 we get Y equal to 200, A equal to 6,000, and then YA equal to 1200,000. And then piece number 2 Y we get 450, and then A we get 100,000, and then Y times A we get 4,500,000. So 100,000 divided by 167, then Y bar we get 356.25 mm. For this solution, we want to calculate the maximum stress, which is the formula is sigma equal to mc per I. So which is sigma is maximum stress, m is bending moment, c is distance from other part to initial axis, then I is moment of inertia. Then for the moment of inertia, the formula is ISS equal to 1 divided by 12 times BH cube, which is ISS is moment of inertia for rectangle, B equal to base of piece or block, and then H is height of piece or block. So from the figure, the value we take and put it in the formula. So we get T227,083,333.33 mm power of 4. So we continue to the next slide. So from the calculation before and from the figure, we can get the moment is 25 kN meter, and then for the C steel 356.25, and for the C concrete we will get 143.75. Then for the ISS, the inertia for the rectangle we get T227,083,333.33 mm power of 4. So the maximum concrete is 1.11 Newton per millimeter square, and then for the maximum steel is 2.76 Newton per millimeter square. That's all for the part of the solution. Thank you.
Lastly, for the recommendation, in my opinion, for construction nowadays, we should use the concrete steel beams for the construction method. This is because the beams are really strong because of the mixture of two elements, the strong steel and concrete, that will make the durability of the beams become high and will long lasting. Furthermore, based on the calculation that have been calculated, shown that the beams are really strong and it will never collapse when it used in the construction because the mixture elements and structure are really great to make for the construction. Finally, it may be concluded that the concrete steel composite beam are really suitable for the construction in the daily life. This is because the composite beam mix concrete and steel elements that will make the beams become stronger than the basic beams that are sold in many places right now. Next, the concrete steel composite beams to prevent the longitudinal slip in the shear connector at the top flange of the universal steel section, and it marked the beginning of the development of completely composite steel and concrete structure. This B24 shown here, there is no connection between the steel concrete slab and the steel beam that support it. The beam will support the entire weight of the concrete. That's all from us. Thank you very much. Assalamualaikum.